In this video, we'll be talking about isomers. The first question asks, are these molecules identical, constitutional isomers, enantiomers, or diastereomers? So these two molecules here, we have a 4-carbon chain with a bromine and a hydroxy group. So when we look here, we have the same thing, only if we draw a line here and we treat this like a mirror, you can see that these are going to be mirror images of one another. Specifically, non-superimposable mirror images. And this means that they are going to be enantiomers. For the second set of molecules, we have the same thing, only we have the molecules in a Fischer perspective. For this one, we have 2 asymmetric centers. And if we look here on this second asymmetric center, the bromines are on the same side. And then for the first asymmetric center, the hydroxys are on opposite sides. This means that they differ by 1 asymmetric center, and therefore there would be diastereomers. For the third one, we have 1 chlorobutane, and then here we have 2 chlorobutane. For the first one, there's no asymmetric center, but here there does exist one. However, since this molecule does not have an asymmetric center, they are not going to be enantiomers or diastereomers. So the correct answer is constitutional isomers. Because they differ by the chlorine. For absolute configuration, this is going to mean R and S. And so for this one, we have 2 asymmetric centers. So this is the top asymmetric center. So the priorities are as follows: 1, 2, 3, 4. And so we need to convert this. So the lowest priority is on a vertical bond, usually at the bottom. So if we draw our rotation, we get R. However, this means the original asymmetric center is S. For the second one, there are the priorities. And we do the same thing. We get the 4 on the lowest bond here. And we draw a rotation, which is R again. However, this means we are going to get S. For the last one here, we have a chlorine on a dashed wedge. And so if we draw on the solid wedge, we have an H here for our priorities. We have this. However, we need the lowest group away from us. So we're going to switch these two. And so we get this. And now if we draw our rotation, it would be this way. So that would be S. However, since we switched the two groups, this configuration is going to be R. And that concludes the video on isomers.